And I'm going to start with why we need it, why it's a good idea to have an API for that. I'll talk about the API itself, how it was developed and so on, and then I will show some code examples. Let's start with why. If you look at the schedule, we are going to green line afterwards, and we're going to represent price of beer in Swedish kronas. That's actual price for most of the beers on tap there. So it's a really nice place. So we can have a couple of options. We can go float, int, long, double, big decimal, probably something else. And all of those have different issues. Float has horrible precision. If green line in had a system with float for price of beer, then if they had to calculate a week's sales or something like that, they would probably run into precision issues. And running precision issues can be really bad, especially when taxes become relevant and stuff like that. We can go for int. Int has always the same precision, so we need to make a decision. How exact do we want to represent the price? Do we want to have it in kronas, in öre, in tens of öre? And it all depends on your business needs, which can be different for different companies. Int has a horrible overflow problem. The largest int is around 2 billion, and you can reach it now pretty fast. Maybe not in a pub, but in a lot of other cases. Long is a much nicer type, for the int at least. You're less likely to run into overflow, but if you were to calculate, for example, world GDP for a given year, and you want to have it sufficiently exact, you might be very close to that level. Double does not have that problem because max double is very, very big, but you will run into precision issues. Big decimal is a nicer type. You can have much more precision there, but it's much more complicated to work with. For example, if you do big decimal 1 and divide by big decimal 3, you'll get an error message instead of something reasonable. You need to take care of rounding, you need to think about a lot of details. Also, it's fairly slow. And when you have so many options, where some are, well, at least reasonably okay, like those 3, which should work in a lot of cases, you need to combine them sometimes. If I write an API where I use long and you use double, at least one of us, probably both of us, will make a lot of errors leading to, well, different kinds of horror. Because money should be really, really exact most of the time. So we do need some kind of common ground, a common type that's easy to work with. Money is a very important type in a lot of applications. We have pubs, we have banking, insurance, online shopping, salary calculations, probably something else. Right now we have no standard type, we have no support for conversions. So if I have Swedish krona, want to have it in Danish krona, it's, well, complicated and a lot of work. Formatting is fairly limited. You could do a lot of things, but usually we want to do more. We want to have good formatting support. So that's why some people decide that we want to have a modern currency API. The API has been developed as a JSR, a Java specification request. The number is 354. There used to be a GEP in the works, but roughly 2 months ago they decided that they do not want it for Java 9 as it looks right now. So it will just be a specification and not a part of GDK. And the reason for that is that Oracle is spending a lot of time right now on project Jigsaw. The project is about modularization of Java, and they do not want to spend, well, they don't want to take the risk of adding more APIs. There is a reference implementation of API. It's called Moneta, and that's coined in a lot of different languages. The implementation is at javamani.github.io, where you have implementation. There is the JSI itself, the API, documentation, examples, links to GCP commit pages. Yeah, a lot of stuff. So if you want to learn more, go there. They know everything. The main people behind the API are Anatol Tresh and Verne Kiel. Anatol Tresh works for Credit Suisse, Swiss bank, so he knows all there is to know about money, or at least how it should be implemented in Java. Verne Kiel is also a fairly famous person. He works, he's a consultant, independent consultant, but he is member of GCP Executive Committee, and probably the person who doesn't work for Oracle who knows most about Java. Well, people never work for Oracle because there are some. I'm not involved in that in any way, I just have to like money. So if you have questions about why did they make it that way, I'll probably send to the mailing lists. But if you want to know how, I can try to answer. So the API is mostly in JavaX Money package, where we have a couple of types. Most of them are, we'll start with currency unit. That's currency, like Swedish krona. Currency uses an interface. The actual implementations are in their reference implementation and maybe in the future other implementations. Monetary amount is, well, currency unit with a number, so like 10 krona. Monetary operator is another interface for doing things to money, like conversion, rounding, stuff like that. Also factory classes and exceptions, and well, a lot of other useful small things. Sub-package conversion has conversion information, where the important ones are currency conversion, and that's, for example, currency conversion from Swedish krona to something, and exchange rate, which is relationship between two currencies. Also, we have a lot of factory classes and so on. I will show examples later. Format has formatting, and SPI has service provider interfaces, etc. And the purpose of this is to make it easy to integrate the implementations with the API and to make it work well with CDI and other dependency injection frameworks. If you want to play around with this, there is named dependency. So you do need an actual implementation, so you need Moneta and not just the API. And to get it, you use standard Maven or whatever you want. This is the latest version as of 3 days ago. I haven't checked after that. So now we have a release candidate 3. So it's still work in progress, but it's mostly done. I did this talk for the first time roughly a month and a half ago. Then it was RC1, and almost nothing changed since then that I could see. So it's mostly small bug fixes and so on. So let's start with getting a currency. Currency you can get using a factory class called monetary currencies, and it's get currency. And here you can send 3-letter abbreviation, like SEK, Swedish krona. You can send in a locale. You can send in, well, currency have a numerical, name, well, I don't know what it's called. And what you get out is a currency unit, which is an interface, and there are multiple implementations. To get actual money, that's the standard way. So we get a factory, and there is a number of different ones in the implementation, but there is a default one. You set number, how much money you want, and set currency. Then do create. Get monetary amount, it's an interface. Interface is supposed to be implemented only by immutable classes according to documentation, and the classes in the reference implementations are immutable. What you would get here is, instead of money class, money class has big decimal as its base implementation, which means that we have a lot of precision and can represent really large numbers without worrying about running out of, worry about overflow or precision. And all the complicated things like make sure to be rounded correctly are handled for us. So Anatole Tresh and Werner Kiel made a decision about what's a reasonable way to do it. Now this is pretty verbose, and very often you want to write something nicer. So if you are using a reference implementation, you can do something like this. So money is a class in the reference implementation and not a class in the API. Yeah, and here we can have more or less anything that's reasonable, so double, long, big decimal works, and here we can have either currency unit or three-letter representation, or again, whatever is reasonable. Local works. Now, money is based on big decimal, which is a very nice type, but it's slow. And sometimes you want to trade precision for performance. And you can do it. There is a fast money class. Now, fast money class is based on long, which means that we have limited precision. And if we try to send in something with this many decimals, we get an exception, because long has limited precision, and the implementation supports 5 numbers, or 5 digits after the decimal separator. And that's exactly what our error message tells us. So the implementation protects us against, losing precision by accident. Now, if we have a number with fewer decimals, like here, it will work very well without any issues. We want to do things with money. We want to add, subtract, and do a lot of other things. The API has support for that. So for add, there is add method, where we can have 2 monetary amounts and add them. The type of as the objects themselves are immutable, the objects don't change, but we get out a new one, and here we get new object. The class will be the same as the object that we call add-on. Now, money has more precision than fast money, so it's not a problem. If turned the other way around, again, we do not lose precision by accident. We get an exception which tells us exactly what the problem is, more or less. But if we have a more reasonable number with the same amount of decimals that we support in fast money, it works painlessly, and the type of this result will be fast money. Now, here in Skåne, we frequently have Danish money, and if we try to add 100 Swedish with 100 Danish, we would get something really strange. And the API, the implementation protects us from that, where we get a very nice exception here. That's exactly what the problem is. We cannot mix Swedish and Danish and expect something reasonable to happen. Of course, sometimes we do want to do it. If I want to calculate my total net worth, and I have 10 Swedish and 10 Danish, I do want to convert them to same currency. And the API has support for that by using monetary conversion to get conversion, so the conversion for Danish, and then I translate my 100 Swedish kronas into Danish. And that's the value I got yesterday, I think. Yes, yesterday. Conversion happens with the help of conversion providers. There are a number of those included in the reference implementation. The most used one is ECB provider, which fetches rates from European Central Bank, and they post it on in a file, an XML file, I think every day. There is also an IMF provider, International Monetary Fund, that posts the same rates all the time. This is the easy way to get the conversion rates. There are also more complex ways where you have much more options, where you can say that I want this provider, or that I want historical data, because, for example, ECB provides historical data. Now, this will lead to network call, because we actually need to fetch it from somewhere. Network calls are slow, as we all know. So this is fetched when the application starts and then updates automatically now and then. If you do not have a network connection for some reason, then there are some values included in the reference implementation. They will of course be old, so not trustworthy, but for testing and so on, could be useful. The values have been shown here, and other places is simple system out print line. Sometimes we want some more formatting. And formatting is based on locales, because in different countries we print in different ways. So we can get a UK locale, which means that our 100 sec with the very many decimals look like this, and it would look like this. Now you might want your own format. Well, you probably do. Most of us do. So there is support for that. I tried to do something really weird, and I got something like this. So I started out by creating a query. Yeah.
How do you? I'm not sure if you're doing that right now, but you're rounding it, of course. There are different rules for different currencies and different applications, complex, whatever.
Yes.
Is that what you're handling right here?
Well, no. This is
Okay.
no. That doesn't happen here.
Okay.
Well, it
So
might.
My question is, how do you handle that? Because well, I've worked with the airline industry, and they have looked of rules that apply to this.
Well, there is. I mentioned operators earlier, and there is a rounding operator, where you provide information about how you want to round things, rules, and so on, and create an object, and then you round them.
But those are not provided per currency, though. They are provided by yourself. You have to.
Yes, you have those. Well, there are also rounding rules per currency.
Okay.
So there is a rounding style, I think. I don't remember the name of the class exactly, but there are default currency rules. So you can get a default rule for Swedish, default for Switzerland. Of course, if you have really, really special rules, I don't know, airline rules for China, I don't know, you might run into issues. So I don't know if they have all different stations, but they do support a lot of different ways, especially the defaults per country.
They do have defaults per currency. That's good.
So I think here it's default to Swedish locale. And unfortunately I have round numbers, so I don't get anything fun here. But now this is pretty purely formatting, so that's what you do when you print stuff. So I have started with Swedish locale, so that I get Swedish name for currency. I have currency style name, so I get name of a currency and not threat abbreviation. I think there are 3 options. There is name, there is code, that would give us SEC, and there is something else. I can set pattern, and my pattern has money in front. The rules are same as for number format, and currency sign again same as number format here. I set group sizes, and that's an array of ints. So I have a group of 4, so my group should be 4. I can also have different numbers. That would mean that last one is 4, and the previous one is whatever it would be. And have separators. Again, same rules. I have question mark here. I don't know why. I get it. The API is really flexible. You could do a lot of stuff by your own. You can invent your own currencies, for example. So since we're at Foo Café, I create a Foo currency, which I have, so the name is Foo. The code will also be Foo. I have a provider here. It's empty right now, but I could do something smart here. Default fraction digits, default numeric code, and build through here means that I actually ask the system to register it. And now I can get it using standard currencies get currency. Of course, I want to have conversions. We need to do something really, really complicated with conversion providers, or write my own. I decided not to do it because it would be a lot of code. It was really strange code. But for business applications or maybe for games, it might be worth it. So, as I mentioned earlier, this is still work in progress. So, if you actually use a lot of monetary values in your application, then you suggest you play around with this and deliver feedback to them, because they do have an active mailing list where they do respond to people's opinions on this and make changes based on what people say. So they are very active with the community and want feedback.